When can double factorial be helpful? So in this video, I'm going to solve a pretty easy integral, by the way, and like try to show how double factorial can sometimes be helpful to synthesize the information. Yeah. So basically, to solve this integral, uh, we can use beta gamma function. Yeah, and it's easy, by the way. So now we know the beta gamma function formula, that is integral from 0 to 1 of x to the power m minus 1, 1 minus x to the power n minus 1 dx. This is just beta function of m and n. Yeah, similar is the case here. We will have beta function of n plus 1 and 1 by 2. Now beta function of m and n is gamma m by gamma m plus n. So we will have gamma n plus 1, gamma 1 by 2 by gamma n plus 1 by 2. Yeah. And now since gamma of k is equal to k minus 1 factorial, that's why this is n factorial by n plus 1 by 2 factorial, and gamma 1 by 2 is just root pi. Yeah. Okay. Now the next thing is the n factorial can be written as n minus 1, n minus 2, and so on up to 1. Yeah, we are just subtracting 1, 1, 1, 1 every time. And similar will be the case here. We will just subtract 1, 1, 1, 1, 1 every time. Yeah, and basically, since n is an integer, the last thing that we will get to is, okay, so 5 by 2 and so on. So over here we will get 1 by 2, and then we'll also get minus 1 by 2, and it continues. But let's write this as minus 1 by 2 factorial. Over here it's root pi. Now minus 1 by 2 factorial is also gamma 1 by 2. This is also root pi, so both of them will cancel out. In fact, these two will cancel out, since minus 1 by 2 factorial is exactly the root pi, because this is just gamma 1 by 2. Yeah. Okay, so now from 1 by 2 to n minus 1 by 2. Okay, so basically over here we will have n number of terms. Yeah, and to show that how there are n number of terms in this, we can I will try to show you in a different way. Okay, so basically let me first write the numerator up to 1. Yeah, so basically we first of all I have 2n plus 1. Yeah, and then over here, if this is 2n minus 1, we have by 2 over here. I do know that. And then 2n minus 3, 2n minus 5, and the last term is 1. Yeah, so now basically from 2 to 2n, from 2 to 2n, there are n number of terms. Yeah, all of us do agree that. So also from 1 to 2n minus 1 also there would be n number of terms. Yeah, so basically over here I can write by 2 to the power n, and over here by 2. Okay, so now we can take 2 to the power n in numerator, and if I do that, what I will get is that will be 2n, 2n minus 2, 2n minus 4, and so on up to 2. And also in denominator I have 1 by 2 times this is 2n plus 1, 2n minus 1, 2n minus 3, so on up to 1. Now let us see what double factorial means and how we can use it here. So basically double factorial means something like this. If I have an odd number, the double factorial will be 5 times 3 times 1, and if I have an even number, that will just be even a number, the product of even numbers. Sorry, not 3, 2. Yeah, so basically for an odd number, that will be n minus 2, n minus 4 up to 1, and for even number that will be n minus 2, n minus 4 up to 2. This is for odd, this is for even. And if it's 0, as always, we define that to be 1 for 0. Okay. After this, the 1 by 2 denominator goes to numerator as 2. And over here, this is just double factorial of 2n. And denominator, we have double factorial of 2n plus 1. Yeah. And yeah, now if we had to write this whole expression or the expressions just before that, yeah, these expressions, it would be somehow messier, and like it will be difficult to convey, yeah, in textbook or a copy. But these expressions like will save space and also synthesize the information, make it more clear kind of, and like help us see like what relation is there. So that's why it can be helpful to convey the information sometimes. So this is the answer, and yes, it was here as well. And hope you saw like how and when can dual factorial be helpful. Not really helpful to solve the problems, but helpful to synthesize the information. Hope you got it. Thanks for watching and look forward to seeing you in the upcoming videos too.